Okay, I think we're live. Hello, everyone. Welcome back. I'm John Ball, the CTO and founder of Pad Inc. and cognitive scientist. And today, what we're going to focus on is the amazing capabilities of role and reference grammar being implemented on a computer system with inspiration from pattern theory, the brain theory that I developed back in the 1990s, well, 1980s and 1990s. So I think it's a very exciting show today because we're focused on predicates, so one of the building blocks of meaning, and we're going to demonstrate how you can start with very simple concepts that we'll introduce, and then how we can get more and more complex as we go. So today, just to point out, Beth Carey is our moderator, and at various points in the program, we'll be seeing questions from the audience. So feel free to ask questions, and hopefully they'll bubble up into the presentation today. Okay, so the power of predicates to represent meaning for machines. Let's get rid of that. A bit distracting when you can't see the screen. Okay, so this was in an article I wrote back in 2018. The fundamental goal of linguistics in 1957, this came out of Noam Chomsky's work. As you can see, the fundamental aim in the linguistics analysis of language L is to separate the grammatical sequences, which are sentences of L, from the ungrammatical sequences, which are not sentences of L, and to study the structure of those grammatical sequences. So to me, that was the main reason we started on the wrong path for natural language understanding, because we're removing meaning and we're focused explicitly on syntax alone. So in my article in 2018, so that's 60 years later, roughly, from Chomsky's goal, the fundamental aim is of a language L. So this is not a formal system, this is a functional system. So what we're studying is the meaningful words and phrases which comprise the sentences of L. We'll study their language-independent representation, so their meaning, and how they interact in conversation. So it's the context in conversation that we're interested in based on the meaning of these phrases that we found in the language. So it's a very different paradigm. So here's the comparison. You can, let me just change that. So you can see here that in 1957 we've got the syntactic representation, which is the goal of the formal system, and in the modern world in 2018, in fact in role and reference grammar for decades, syntax links to semantics. So word phrases and word meanings link to the meaning of those sentences using the role and reference grammar linking algorithm, and they go backwards back to the language that generated them, because the system's bidirectional, and it does it in terms of discourse pragmatics. When we say discourse pragmatics, we mean context, or the way we're using discourse in a language. So that was the goal. Comparison 2018. So we're bringing meaning into the system. And why is that? Back again with in the 1950s, there's this famous sentence, "Colorless green ideas sleep furiously." And the argument was, and we'll talk about this in the next program in detail, but the argument was that if you can work out the grammar, it's independent to meaning, because colorless green ideas sleep furiously has zero probability of occurring in language. Well, why is that? Well, you can't be colorless and green. You can't be a colored idea, because ideas are abstract. You can't have ideas that sleep, because only animate things sleep. So we're violating all the selectional restrictions of the meaning of that particular sentence. But the point that I make is that that was the thing that set us off for the next 40 years, focusing on syntax only. But notice this next sentence here: runnings run furiously. That's simply substituting in the valid structure for English from that first sentence. You just substitute in other words, and it doesn't make sense. It's no longer syntactic. So the idea that you can study something that's not bidirectional never worked. Okay, so here's our goal today. I'm going to talk about what predicates are. We're going to look at the different kinds, and we'll do that in a bit of detail. And then we're going to look at, if you think that's too simple, we'll add junctures into the mix. And if you think that's too simple, we're going to add these interclausal semantic relations into the mix. And by that point, you're going to need to have a week off so that you can digest all of that and maybe watch the video a few times, and then we'll come back. Okay, so what's a predicate? This is the Semantics 101. This comes from this diagram on the left is the layered model from Van Velen's 2005 book. And what it's showing is that at the center of any sentence, you have a predicate. It's over here, that you have a nucleus, and then there's a core around that. So that's the nucleus plus arguments. And then around that, you've got a clause, and around that, you've got sentences. And you've got detached phrases that you can put in English in front of the sentence, in other languages behind the sentence. So this is a universal model of how the world's languages work. And if we take an example on the right, this is actually slightly updated terminology for those of you who have an incredibly keen eye. Notice we've got pre-detached phrases here, and here we had left detached phrases. And one of the RRG experts asked the question, why do you call it a left detached phrase? And it was from a language where they write right to left. So the left detached phrase was actually on the right. But it's actually the phrase that comes first. It's the pre-detached phrase. So well picked up for anybody who noticed that distinction. But notice here we're saying, as for Mary, what did she eat after lunch? And if you try and write rules for this, it would be very complicated because you're going to have, I don't know, hundreds of thousands or millions of rules. But in this case, in a pre-detached phrase, Mary gets substituted for the word she somewhere in this main clause. So as for Mary, what did she eat after lunch means what did Mary eat after lunch? And we've got various phrases here, the time being inserted into the periphery of the core and so forth. So a lot of technical stuff. Don't expect you to pick that up today, but we'll be going into more detail in future presentations. So finally, we're just going to look at the difference between grammar here on the left and meaning here on the right. And the reason becomes obvious when you see a few examples. So on the left here, we've got the layered structure. We've got a nucleus, which is normally the predicate. We've got a core, which is normally the arguments of the predicate. Then around that, we've got when and where, so you can ground any concept in time and space. And then at the clause level, you can have a reason, which is further explaining what this predicate means. And then it's got a periphery, which could be like an evidential. So if you were to say, it is evident that John is happy, you're not saying John is happy, you're saying you have evidence for that, but whether he's happy or not may not be true. So when we map from the syntax here to the semantics, if you said John is in the kitchen, what we're doing is we're saying John is this centerpiece here, but the predicate in that case is we're grounding in time and space. So it's one of these, it's actually a periphery that we're not drawing in this particular diagram. Okay, so there's the introduction. There's a lot there, and it always becomes a lot clearer when you see it in action. So what are the predicate classes? There's basically 24 building blocks of the world's languages. So we've got states, we've got activities. The difference is that states are things that you can only describe in certain ways. So if you said Pat is a fool, okay, well you're putting Pat in that particular state, but you can't say Pat is vigorously a fool because that's not how states work. They're just these continuous relationships. Whereas if you said the children cried, you could say that the children cried quickly because you're basically adding to that particular activity. And the constraints, once we get through all of this, you've got a whole bunch of these basic building blocks. And you can have causation for each of those basic building blocks. But as we go on, we now have tests to work out how does this expression relate to the language. And the reason this is really important is if you want to work with a meaning-based system, you need to make sure that something makes sense for the words that you're using. So, for example, if you said Dana is being tall, or Dana is being tall, that doesn't make sense because that's not how you can use state. So there's one of the basic tests. Max is vigorously tall. Makes no sense. You can't be vigorously tall. You can be, I don't know, vigorously talking, but you can't be vigorously tall. So by simply following these tests that come from role and reference grammar, and it applies to any of the world's languages, you're able to work out the meanings of these basic building blocks of language. Okay, so let's see how that works. Okay, so here's our interface. I've got a few samples that we can look at. Let me just bring up a few because it's easier to demonstrate than describe. So we've got here, the car shouldn't have been cold. A little bit small. Okay, so this is actually the first building block I'm introducing. So notice here that we've got the car in brackets and cold. So there's our predicate cold. It's a state. And then here's its argument, the car. So we're saying that the car has this state of being cold. In our system here, we've also got a bunch of other words. And, why am I showing you a complicated example to start with? Well, this is how language works, and children have no problem, so I'm sure you won't either. The car shouldn't have been cold. So what does should mean? It means it's possible, and it also means low obligation to do it. So there's a bunch of things that are coming into play here. Shouldn't have been cold. We've got, we're showing past tense because should is like the past tense of shall. We don't really use it that way anymore, but we're just capturing the information that's interesting here. Have been, that is a perfect aspect. So notice down here we've got perfect aspect. So what our system's doing is it's ripping apart this very simple sentence, really, and then it's breaking down the meaningful components and displaying it on the screen. We'll go a lot faster in a moment, but let's just do a comparison here. So there was shouldn't have been cold. Let's change that to could, for example. So now if you could have been cold, now we've got, it's still past tense because could is like the past tense of can, not really anymore, but that's how it came from. It's a possibility and you're able to do it. So could has a different meaning to should, and notice here we've now got positive polarity. The previous one would have been negative polarity because it was shouldn't. So all of that information is being applied to this particular predicate representation, semantic representation. So the whole thing is really the semantic representation that you're seeing here, but this piece here is the thing to watch for, particularly in this presentation today. So that's one type of state. Here's a different one. John was tall. It's simply being shown in a slightly different way. This relates to how other languages work, so we're simply mapping that into English here. So John is tall. So here we've got the predicate inside these brackets, and John here is the patient, the undergoer that has that particular attribute of being tall. And there's another way we can show that. Beth is happy. In this case, instead of be, we've got feel is the relationship controller because we've got a feeling taking place here. And in this case, the feeling is Beth having that property of being happy. Okay, so there's our first one-role state. Now we're going to accelerate. Here's a two-role state. Predicate operators. Yep, we'll do that in a moment. So Bill knows Sam. So here's a two-role example. In this case, inside the brackets, we've got two arguments, Bill and Sam, and we've got know, which is the predicate, and now we've got an actor and an undergoer. So notice here we've got labels for them, location and theme. So that's a two-role state. We can now make things more complicated by making it causative. Beth showed. So here there's a two-role state. Beth showed the man her red car. So in this case, what Beth is doing is causing something. What's she causing? She's causing the man to see her red car. And you can drill down into her red car and get the meaning of that. So there's a lot of information now coming to bear on these types of problems. And in this case, notice we've got Beth doing something. We haven't specified what it is. It's a causative predicate show. And you have to understand what the meaning of causative means. It means there's some activity taking place that results in that other action. And so the more you see the breakdown of language, the more you realize that causality is really baked into how languages work, because that's one of the things that we're very interested in, the cause of things. And you can compare that to see. So notice here, this is a two-role state where somebody sees something. So those are states. Now we can look at activities. The main difference in terms of introducing our predicates is that activities have a different format. So here we've got she is doing something. What's she doing? Because this is an activity. She's eating sandwiches. So eat is a two-role activity, not a two-role state. And that's how we can see that. Now notice here that if you're eating sandwiches, you're doing this activity, but there's more that we can get from a sentence if we add something to it. So you can eat the sandwiches. So now if there's a bunch of sandwiches and you eat them, then the sandwiches at the end of that activity are consumed. So notice here in our representation, she does that activity, eating the sandwiches. And then at the end, there's this change of state where the sandwiches have been consumed. So there's no more sandwiches. The reason this is important is if you're not able to track what's going on with the arguments that you're working with the things that you're working with, then if you were to say, can I have a sandwich after, in this case, she ate the sandwiches, then, well, no, there's none. And that would have to be the correct answer. So we need to be tracking all of the meanings that are taking place through these simple sentences. And we can get more complex. She ate the sandwiches with chopsticks, so now we're using an instrument. And notice here we get instrument down at the bottom. But there's not too much of a change. We've got her eating the sandwiches, but at the same time, that's that symbol there, she uses chopsticks. So she's still eating the sandwich. It's the same activity, but her tool to do that is the chopsticks. And notice at the end, the sandwiches are still consumed because we're not changing the meaning in that respect. We can have causative for eat. So here's feed. In this case, notice that Bill causes something to happen. Bill does something unspecified, which causes the children to eat the cereal. And the reason it's important to get all of the syntax right is the meaning comes from what we've recognized. So if you feed cereal to the children, that's going to be the same thing as, let's just show it, feeding children cereal. But you have to use different words so that the system can recognize it correctly. Fed the children cereal. So notice if you feed the children cereal, the children are still eating cereal. It's not cereal eating children or cereal causing Bill to eat cereal. So it's very explicit how this works once you understand English. And as this is the introduction, again, the main focus is the difference between state and activity, and then there's these additional extensions that we can see for achievement, semifactives. And here's one that we've looked at earlier, the balloon popped. We prepared earlier. So here we have this thing called INGR. So the balloon pops, so that's a state, but INGR means that it wasn't popped at the beginning, and then over an instantaneous change of state, now it is popped. So we're tracking the change of state. And ingressive is called an achievement. So that's the instantaneous change of state, but there's other types such as accomplishments where it takes place over a period of time, like melt. So here with the snow melted, you can see we've got the word become in front of the state of the snow being liquid. So over a period of time, the snow is melting, not an instantaneous change of state. And then you can have causatives simply introduced by adding additional arguments. So the cat popped the balloon. We had the balloon popped. If the cat pops the balloon, it's the balloon that pops. So notice here in our representation, it's unchanged from the balloon popped. And this is important because if the cat pops the balloon, did the cat pop? No, the balloon popped. And you have to recognize the meaning of that sentence. So here the cat does something which causes this instantaneous change of state to the balloon. And it's the same meaning, it's the same predicate for pop, it's just that it's serving a different function for that sentence. And then we've got snow melted, we can have somebody melting snow, again, that's causative. And in other respects, the meaning is unchanged. It's still a change of state, to a state. And then here's the special exceptions. The man is in the garden. So in this case, in the garden is a where location. There's no nucleus being shown here in its meaning representation. But it's a state, which is the man is in the garden. It's working from right to left in terms of reading it the way you say it, because the man is the undergoer. It's the rightmost argument. So the man has this state of being in the garden. Notice that in the garden is what we would have termed prepositional phrases 10 years ago or something, but it's actually in terms of meaning category, it's a location, it's a position. So if we use another position word like here, notice that that girl is here is the representation. So we're using the meaning to create the representation. Otherwise, it could be somewhere not in a layered model. Okay, so the question that was asked is a little bit more. I think it was about the modality, and if we take any sentence, operators. Okay, so one of the breakthroughs that Roland reference grammar came up with, it was in a Stanford course many years ago. One of the students pointed out that you can just pull these elements out of the meaning representation and store them against the entire sentence. So those types of things became clause level operators, other things became core level operators. So instead of having to work out how it relates to particular words, it's relating to the entire sentence. So if I clear this here and we just show a couple of building blocks, if we start with somebody being tall, all sentences have this thing called illocutionary force. It's a statement. It's the interpretation of this representation. It's a statement. It's got positive polarity as opposed to the man isn't tall, and it's present tense. And because those things apply to the entire sentence, we're showing them here as operators against it. But in certain modalities, the man will be tall, for example. Now, the word will has its own operators that are provided. So it's a compositional system, language, or a combinatorial system is the other way we like to talk about it. So in that case, we've got will means certain. If you will do something, you're talking about the future, and there's no doubt about it. And it's got high obligation, as opposed to should. So if you will do something, it's certain that you are doing it, so you've got obligation to do it. As I should do it means that there's a low obligation to do it, but you should. And it's very complex how the modal operators are decomposed like that, compared with the more simple ones like did and is and so forth. But notice we've just got a bunch here. So and again, we're decomposing will as present to contrast with would, which would be historically past tense, and now they've got their own meanings. So if the man would be tall, we've now got past tense, because would is like past tense of will, but it's still possible, because that's one of the differences between would, and it's still high obligation. And as we play around with these, we're going to get a huge number of combinations, which is why if we want to do a deep dive into one of these things, we can take an entire hour and just go through the detail of it. So the man wouldn't be tall. Now we've got negative polarity for the entire sentence, but we've still retained the possible and the high obligation. So operators is a big breakthrough for people who are interested in NLP, natural language processing, because it makes the recognition of sentences much simpler, because you're simply pulling these operators out and applying them to the correct part of the semantic representation. Does that make sense for that question? Yeah. Okay, good. How many combinations? So I talked about 24 basic building blocks of meaning, and that came from my earlier slide. Let's just go back to that one. So these are the building blocks of predicate classes in the world's languages. We've got states and activities that we've been looking at in detail. You've got achievements, which are those instantaneous changes of state. So that's the INGR property. You've got semifactives, which are things which change state but then come back to the same thing. So like clapping is a instantaneous change of state, but then it's gone again. So there's no change of state. Those are activities. And then accomplishments, which are the changes of state over a period of time, where you're seeing the operator, you're seeing the word become. I try not to use the technical linguistic terms as much as possible, because that's, as a cognitive scientist, those are the ones I tend to get wrong. I'm much better at implementing what I'm told to implement when you've got a good theory like this. And then there's active accomplishments, which are like if you eat something defined, then that thing has been consumed. So if you eat pizza, we then add that ingressive, that instantaneous change of state, because you're eating and eating and eating, and then suddenly there's nothing left. And then for each of those, you can have one roll or two rolls. In fact, there can be 0 rolls, like raining. And then there's causatives for each one of those, where you basically have some unspecified activity causing something to happen. Okay, so it's a good building block start that role and reference grammar uses, because they've looked at the world's languages, and here's the building blocks. Different languages like Japanese and Russian may well use different types of constructs to English, but it's still using all of these building blocks, and that's the reason we can take the building blocks for language from RRG and then store in that particular format and then use them for any of the world's languages. Okay, so let's keep going. I know a lot of you were probably thinking just at that point, this is way too easy. Languages are much more complex than that. So let's just ratchet things up a couple of levels. So nexus and juncture. Just think of this as how we can use the word and or in a language, and suddenly you start going from very simple expressions to much more complex expressions. Sorry, there's a question here. Very cool, John. Querying against these properties could be very powerful if a dev, what's that say? If a dev understands how they work. Yes, exactly. Thanks, Connor. Great point. And look, the reason I find this really exciting is I'm a dev as well. I was looking for how we can use this technology for the improving AI. And the thing I wanted to be able to do is, from the 1960s Star Trek movies, I wanted to be able to talk to a computer, have it respond to me in language, understand what I'm saying even if I'm not speaking like a computer, and then be able to get things done. And so what I've just shown you, those building blocks we've then used to store the meaning in conversations as context, and then we've asked questions about them. And in fact, I'll show you in a moment how you can do question answering with this system by understanding what the relationships are. The reason the distinctions are important too is if you say, I should go to the beach, and somebody were to say, did you go to the beach? The answer is no. Like, you should have, but you didn't. If you had gone to the beach, you would have said, I went to the beach. And those little distinctions with this massive amount of information, once you start to control that in conversation, now you're working the way human brains can work. Okay, so here's the types of connections that you can get in language. You can combine units like and coordination. You can get subordination, like you did this, and then there's some more complex sentence that you're using to explain that particular fact. Those were the only two building blocks that were available in the rules-based models of the 70s, 80s, and 90s. And then RRG's breakthrough is this concept of co-subordination, where you have the ability to share arguments. You can share a nucleus, you can share arguments, and that allows you to communicate very complex concepts with very few words. And we'll see that. On this right-hand side, you can see a bunch of examples of the different types of junctures possible. So, for example, if you seem tired, there's this seeming taking place for Max, or for this event, and Max being tired. So all of these are then demonstrable in the system. Even just with reference phrases, so John and Beth, or the cat and the dog, or the cat that I saw yesterday and the dog that I saw today, those types of combinations then make your language infinitely more flexible. It's one of the reasons why corpus linguistics, or the current approach for data-driven language, doesn't work, because there's so many combinations that you get once you start using these nexus and juncture and types that you could never get enough data. You know, the simple example that I showed was, if you just look at motion in English, you've got like 10 to the 3,000 combinations of words for a very simple, with some very simple assumptions being made, you know, maybe 20,000 predicates and 40,000 reference. The combinations possible for motion is 10 to the 3,000, and a large corpus these days might be 10 to the 12. Maybe you could get slightly bigger than that. So the orders of magnitude are so ridiculously big in real language that you can't do it with data. And if you had that much data, you'd never be able to process it in real time. It would be one of those things you'd start now and it would finish in, 100,000 years' time. So that's not the solution. So you can see here the big dog and a little cat. There's one type of juncture versus the big dog and little cat, where you're not sharing that determiner between. You are sharing the determiner between the two elements, and so forth. Okay, so you now know what's coming up. I'm going to show you junctures, and then you're going to say, but that's too simple, and then I'm going to show you the next level. And this is all stuff described by Roland reference grammar going back decades. So let's go back to our demo here, and let's load in another file I've prepared. So here's some junctures. Let's just step through them. Notice Beth and John are happy. Beth and John is now the patient, and we very kindly put Beth and John here with nice labels 1 and 2 for Beth and John. And I might have said this on a previous broadcast, but we're using the model from George Miller from Princeton. That's where I remember him from. He was either at Harvard or MIT prior to that. But George Miller, as one of the founding cognitive scientists, he came up with the idea in the 1950s that people can keep track of 7 plus or minus 2 concepts. So for this system to be fully capable, human-like language understanding, we're allowing up to 9. I'll show you an example with more than 2. But so we just simply list them, and then as a developer, you're going to get this list of things that have these particular properties, or they're part of some sort of predicate, and we're resolving what that can mean for you automatically. But the end result is you're getting stuff like this, where in this case the compound or conjunction Beth and John have that property of feeling happy. And you can not just take the patient element, you can take the predicate element. Now we've got is tall and young, Beth is tall and young, and that's now the compound predicate, and there's Beth as the patient. So in that case, the predicate is the combination. And now the juncture part is words like want. I was always confused as to what want means. I no longer want for that. So here we've got Beth wants to be tall and young. We've got want Beth be tall and young. Beth. Oh, so why is Beth over here as well as over there? Well, we're sharing the argument between the two elements. So here we've got the meaning of want. Somebody wants something, and until you get to the rest of the sentence, you don't know what they want. So X is unspecified. So as the sentence progresses, what we're doing is we're passing Beth on to the rest of the sentence, and that allows us to resolve the rest. Beth is tall and young. So notice, just because we've got these junctures inside here, we're also allowed to have a juncture between want and the rest of the sentence. So the rest of the sentence means Beth is tall and young. We combine that with want Beth X, and we get the meaning of that. So you can think, wow, that's pretty simple. Why didn't we think of it before? And the reason we didn't think of it before is it becomes it's not just one way of doing it. The world's languages have different ways of doing it. Let me just look at the question that's come up. does this mean you would preclude the system from being able to track more than 9 concepts for realism? No, it means that if we're building an NLU system, if we start with 9, and that's good enough for consuming, for reading any human written document, then firstly, it means that we're going to be able to read everything that humans write. And secondly, it means we'll be able to generate something that somebody can understand, because this is a bidirectional system. So if we have meaning that allows 9 elements to be stored, and then we push it back into a target language with those same 9 elements, then the human being at the other end is going to understand it. Whereas if we have no boundary on it, we're not building it for humans. Sure, I could just generate 10,000 possible answers, but firstly, it's going to take a long time to get the answer out, and secondly, nobody can follow it. So thanks, Michael, for that question. Okay, so wants. Now, want was a state. Here's try. Notice that try is the form of an activity, and Beth tried to be tall and young. So you know that try has a different meaning. We can look here on the definition, which is to make an attempt, and we then get our representation. So we're not going to go over these in detail, but notice tried to be tall and young, tried to eat the sandwich and cereal. We're starting with the same beginning, Beth trying to do something, and in this case, it didn't have to be the thing that we had. It can be anything. So in this case, Beth is eating the sandwich and cereal. So it's this combinatorial use of language that you just see more and more now that you're into the juncture phase. And here's probably the example of a larger scale. And we've got the input sentence, Beth, John, Bill, the old dog. That's a normal reference phrase. And the cat that saw the dog, that's a complex phrase, sentence on its own really, tried to run to the store. So that bit there, Beth, John, Bill, the old dog, and the cat that saw the dog, that's one of the ones that used to take our parsers a lot of time as it's going through finding possible matches and excluding them for statistical reasons or other rules-based reasons. And what it's saying is that compound actor, all of those things, tried to do something. What did they try? Well, in this case, they wanted to go to the store. So here in our representation of run, which is our predicate, we've got covering the path, where at the end of that, the finish point, fin, all of those entities are at the store. And we can go through all the decomposition, but if we drill into that, notice we're nicely pointing out 1, 2, 3. 4 is the old dog, which is that complex sentence. So there's the dog being old. It's important to be able to track that. If somebody said, was the dog old? Yes, it was. Why? Because that's what you said. Or this sentence, the cat that saw the dog. And if we drill down into that, and its meaning, the cat saw the dog. In the case of the cat that saw the dog, we're talking about the cat, but we're providing more context for the whole sentence, which is carried forward when we're entering that into context. So that's kind of cool, and I think it highlights the point. Now, the last type of juncture I'm going to highlight, and as you know, as I've said, I can go on for hours and hours just about these junctures. But let's just make the key points here. The word make is a very simple type of join. It's causative, where everything after Beth is being caused, and Beth is carried forward into... Beth isn't carried forward into the rest. So Beth made John clean the car. So it's like saying John cleaned the car, and then Beth made. So that's the cause. So John cleans the car is the end result, and John causes the car to be clean is the end result, and Beth causes that to happen. So our full representation is here, lots of causality. Beth does something which causes John to do something which causes the car to become clean. Right, so there's one of the reasons why a lot of people talk about we need more causality in our NLU systems. It's because that's how language works. It's just completely saturated in our languages. So there's make, and you think, wow, that's great. I've solved all of the world's problems. I'll come back to that in a second, Michael. Beth promised John to clean the car. So what's the difference between made and promise? So in this case, promise is more complex. It's Beth saying to John, Beth promised John, Beth says something to John, and that causes Beth to become obligated to do something. Now, the rest of that sentence has to have one of these arguments shared with him, because this is the type of relationship that's there. So if Beth promises John to clean the car, then notice Beth cleans the car. So Beth causes the car to become clean. So for some reason, with promise, we're taking the actor from the first part of the juncture, and we're passing it to the second part, so Beth performs that action. And if we persuade, this is a different type of predicate type. So if Beth persuades John, then John, the undergoer, is the thing passed to the rest of the sentence. So what does John want to do because he's persuaded? He wants to clean the car. So the difference between promise and persuade, these are famous examples from linguistics, but promise and persuade are different ways of passing information through. So it can be done semantically by actor and undergoer. It can be done syntactically by whatever was presented first in the sentence. And you can see here, if we use the passive, John was persuaded by Beth to clean the car. Beth persuades John. We're still getting the same meaning, even though it's a passive example. And then we're generating the correct association on the other side of that juncture. So very important. Language has to work, and NLU has to work, otherwise we don't have NLU systems. And on top of that, we've got this layered structure. So whatever we're putting in these main predicates, you can then ground in time and space. You can ground pieces of these predicates in time and space, and you can ground the whole thing in time and space, and for reason and with evidence. So here's Beth persuaded John to clean the car today. You can see Beth persuaded John. Then we have our juncture line. John cleans the car. Remember John, because the undergoer of persuade is the one carried forward to the other side of the juncture. And then we're grounding it with when and where. So today in the kitchen. So when we go to our full representation up here, we've got when today. We've got our location in the kitchen. And then you've got the rest of that semantic representation in here. I've got an error here. So we're not correctly seeing this, because she wanted him to be unhappy. Interestingly, I can't see reason. Don't know why I'm not seeing reason on the screen, but him being not happy is showing in the logical structure, but for some reason we're not getting the display here on this screen. Strange. Okay, well, there we go. Live stream, that's what happens. What was that question that we were looking at a moment ago? Is this covering path fin, be it X, an implementation of RRG, or is it an additional consideration you've made? In terms of the linguistics, there's a really big change coming up. So let's just go back here. There's a very big change that's coming up with the next book for RRG. It looks like it might have slipped to next year now, the Role and Reference Grammar book. But what they've done is a lot of improvement since 2005 over how these activities work and what the end states are. So Rainer Oswald is a Heinrich Heine University academic, and him and Van Velen have worked together on some of those changes. That particular change comes from Rainer, I believe. And so if you finish at that particular time and the path, and the fact that you can go over paths, and you can start at a particular place and finish at a particular place, all of that's been rejigged to be much better. I think another example I can think of that comes from RRG's latest update is cools. So if you say something cools, it doesn't mean that it is cold at the end. It means that it's cooler between the start and the end. So lots of little improvements like that, which are now part of the model. Okay, so oops. I also see the system can organize sense and polarity, but what about representation of aspect? Is that recorded too? Yes. Yes, aspect is recorded. Great question, Michael. Let's just look at aspect. Let's see. So we'll start with the man eats. So here we've got the representation. The man's eating something. We don't know what it is, but eat is a two-role predicate, so we've got the unspecified element there. Aspect is displayed down here because it's a core function of the predicate. It's not a clause level element. So there was nothing showing there, but we can now step through the aspects of English. The man is eating, so that's progressive. So we've got progressive aspects showing down here. And there's nothing different here at the clause level, but we're seeing progressive aspect down there. And that just means that at the time that you've made that statement, there's something happening. The man has eaten. So in this case, this is the called perfect aspect. So we're seeing perfect down there. Haven't been focusing on the word senses, but the word eat here is unchanged. So the concept of eating is unchanged, but now the aspect says, in the case of perfect tense, this is the completed activity we're thinking of. You know, the whole thing has been eaten, as opposed to, cool, Michael. The whole thing has been done as an event, as opposed to is eating. You're talking about something in progress. So those are the two very basic building blocks of how people work. And just to continue, because hey, I'm on a roll, we can combine them further. Has been eating. So now we've got progressive and perfect. And the last one that I'm sure you were wondering about, will have been. So now we've got modality, so we're entering certain and this high obligation in the a core operator, and then you've also got the progressive and perfect aspect. So all of this stuff requires very few patterns comparatively, but if you don't have the operator concept, you're caught with very large numbers of combinations that you've got to deal with, and the combinatorial explosion is the killer of NLP. Okay, is this too simple? I know that's what you're thinking. And now we've got interclausal semantic relations. Can you read any of that? Probably not. Let's make it slightly bigger. So for me, having 2 pages of the 2005 RRG book that shows all of these relations for the world's languages again, it's just a great insight into how much further we can take NLU. I've demonstrated a whole bunch of these, and you'll see them in action again in a moment. But you've got causative constructions. We don't have an example there. Phase constructions. So this is where we're talking about. You've got an activity like crying. If you start crying, now you're focused on that temporal event of crying, but you're talking about the start of it. But in language, you can focus on the end of it, finished crying, or you can focus on the fact that it was ongoing before you mentioned it, kept crying. So all of that is described here with phase. And as you go through, you start with these very tightly coupled, typically causal type relations, through to the very end where there's different events happening at the same time. The baby was crying and John was eating a sandwich. So completely separate things that you're combining. But these types of interclausal semantic relations are drivers of NLU. If you can't deal with it, you're not doing NLU properly. So let's go back and demonstrate that. And again, each one of these is worth having a. Actually, how are we for time? Yeah, we don't have much time, so let's just highlight why we're doing this again. So I'm just going to run this sequence. The man bought a car from the dealer for $1. So we're looking at, why do you care about states and activities? Well, firstly, you need to constrain them to know whether these things make sense. So if somebody's saying something that doesn't make sense, you don't want to recognize it, you need to query it. And secondly, if something does make sense, then when you're responding, make sure you're considering that in your answer. So here, because we've got a meaning-based model, if and I showed this last time, if you buy a car, it means that a car was sold, but you have to know how these arguments are relating to each other in the semantic representation to give the correct answer. So the dealer is the one that sold the car. Who received the car? The man did, because the man bought it. Here's a different predicate type. Who did the man pay for the car? The dealer, because the man bought a car from the dealer. So people can do all of these things. It's a bit mind-bending if you do these quickly, because we tend not to jump between predicates all the time. We're trying to be clear, so you'll probably use the same thing, who bought what. But why does this work? It works because if we take this sentence here, and we'll put it into our meaning matcher. If you're buying a car from a dealer, notice that we've got these arguments down the bottom that we're breaking up into pieces. So we've got the dealer is the source of this exchange. So let's not worry about the details too much. If I come back here and I change one of the words, the man bought a car from who for $1. Notice that who is now sitting inside our representation. So somebody who doesn't have the car. If you want to answer this, you simply look at the one that made sense, the dealer. You've got the question who, and so the answer is the dealer. So very powerful tool for developers to have questions come in and automatically get the answer without having to do the hard work that the system's doing. And I probably shouldn't have shown you a complex sentence like that to make it an example, but the point is this works whether it's a simple predicate or a complex predicate, because the principles are just the science of role and reference grammar. And now let's finish up with some interclausal semantic relations. If we decide to run, what we're doing is we're taking a relationship here, the concept of deciding, and then we're sharing an argument to get the running bit happening. So what does decide mean? It means somebody decides to do something. I think it's a propositional. No, see, I won't talk linguistics because I'll get it wrong. This type of association is just telling us that Max is the one deciding to do something. And X can be absolutely anything. Again, that's why the entire language can be embedded here. In this case, Max runs. So what does that mean? It means Max moves, the manner is running, and we haven't specified the path, but we can do that. Yep, one final question. Okay, Beth, let me just step through a couple of these. So decided to run, decided to be happy. So here's what would be traditionally called an adjective. Max feels happy, Max decides. So we've got decided, Max feels happy. We can go on and on. Fred endeavored to be happy. So here's a slightly different juncture here with be happy at the other end. Notice being happy is shown there. And so on. So what was that question? Because I think we probably reached a good time to wind up. There's a lot of discussion about causality in AI today. How does causality in language apply? Look, that's the key point, isn't it? Today's NLP systems are working off this idea that you can take data and by statistically connecting these word vectors that you build by a process, that by taking those word vectors and then doing comparisons, you're able to work out what something means. And that type of technology works best with, I see these words which are similar to these words, and so now I can use my chatbot and say, well, your intent was the similarity between these word vectors and those word vectors. But the reality is that causality is a different concept. It's something result is the precursor to that happening, and that's how people think. So if you're taking the intent-based NLU models and then trying to do causality, you've got nothing to work off. And the experts in the field, like Judea Pearl, point out that you can't get causality from simply this statistical platform. So causality is genuinely baked in. It's saturated in our language. The cat popped the balloon is fundamentally about the causality. It's the cat causing the balloon to pop. So you've got the change of state from the popping, and you've got the cat causing that to happen. And our goal in NLU is to make sure that we're dealing with causality and these other relationships correctly. And so for that quick introduction today of what these predicate classes are, you can see that as we start joining things, we get more and more complexity. But by doing it very precisely and retaining the causality, retaining the embeddings, not losing the information that's in the language, we're then in the right position to start to build these next generation systems where we're taking human language, storing it in lossless meaning repositories, and then generating it into target languages to really revolutionize the field of natural language processing, natural language understanding and generation, to make really good tools for humanity. So I think at that point, if there's no more questions, we'll call that a day. And I'll say thank you very much to our moderator, Beth Carey. You're welcome. And look forward to talking to you again soon. The next planned one the next planned presentation of this type is to look at what the real roadblocks were in the past that stopped us getting to this now inflection point where we're able to go forward with meaning-based NLU systems. So thanks again for joining me. Thanks for joining us, and see you again soon. Bye for now.